Okay, hello guys. Welcome to the first session of our DBA Beginner's Guide. I'm your older friend, Peng Wang, the global technical evangelist for OceanBase. Today, we are diving into an essential topic for any database administrator, database migration and synchronization. In this lecture, we will explore how to effectively migrate data to OceanBase, discuss the key tools and methods for keeping data synchronized, and look at the best practices to ensure smooth, reliable transitions. Whether you are moving data for performance improvements, disaster recovery, or scaling up, mastering these techniques will equip you with crucial skills to manage OceanBase with confidence. Let's get started. There is a lot of content about OceanBase data migration and synchronization, so we divided it into two lessons. Today, we will talk about the first lesson. It includes the introduction to OceanBase and MySQL capabilities, introduction to OMS migration and synchronization, and the last part is introduction to 𝘖𝘠𝘬𝘵𝘁. Okay, let's look at the first part, the introduction to the compatibility between OceanBase and MySQL. Why is it placed in the first part? Because many of our users are currently migrating from MySQL to OceanBase. In this migration process, the first thing we need to pay attention to is compatibility. If some MySQL features are not incompatible with OceanBase, the migration process will fail, or various problems will arise after the migration. So let's first introduce it together. Okay, compatibility primarily encompasses several key areas. I have highlighted some of the main compatibility aspects we focus on daily use, including data types, chart set, collection, index, and partitions, and other relevant factors. First of all, regarding data types, OceanBase Community Edition is basically compatible with all MySQL data types, except for the serial type, which is not yet complete. But serial is just an alien, so we can use the directly normally, even if they don't use the serial type. Next is the string comparison. Because OceanBase's underlying storage is different from that of MySQL, there are some differences in string storage, such as varchar, char, binary, blob, and others, which all have some difference in length. If you're interested, you can learn more from the OceanBase official website. Next, let's look at the chart set compatibility comparison. Each version of OceanBase supports a different chart set. With each iteration, we are steadily expanding the number of compatible chart sets. This table shows the compatible chart set of OceanBase version 4.2.1. For subsequent versions of OceanBase, such as version 4.2.2 or the version 4.3, we can use the command show chart set or show collection to view the chart set and the chart set and character size and character sequence compatible with the current version. For version 4.2.1, it's currently compatible with UTF-8 MB4 and GBK, and also UTF-16 chart sets. If we migrate from MySQL or PGSQL or from other databases to OceanBase, there is an incompatibility of chart set or collection. We need to make an assessment. What chart set or collection should be used after migrating to OceanBase, which is more suitable for our current scenario. Next is the comparison of indexes. Currently, OceanBase does not support the following index: index extension, descending index, full text index, hash index, lock option, and index image. Index merge. Full text index is the product iteration plan of OceanBase. Let's look at the partition compatibility comparison. There are still some difference between OceanBase and MySQL. OceanBase currently supports primary partitions, templated and non-templated secondary partitions. MySQL currently does not support non-templated secondary partitions. OceanBase's secondary partition supports hash, key, and range columns, and list. Also list columns partitions. MySQL currently only supports hash partitions and key partitions for the second phase of partitioning. The third is the truncate operation. When creating partitions, truncate operations are often performed. When truncating partitions on OceanBase, the entire table will not be locked. But MySQL, because its server and storage engine are separate, and will perform a table lock operation when truncating partitions. For a detailed introduction to compatibility, if you are interested, you can visit the OceanBase official website. Let's learn more about other compatibility comparison. For example, procedural languages. OceanBase is compatible with most of MySQL's procedural language, including store procedures, custom function, triggers, and exception handling, in addition to data types. OceanBase also supports some other unique PL system package, including DBMS Resource Manager, which is used to make some resource restrictions. There are also others like DBMS This, DBMS UDR, and others, which are also supported by OceanBase. In the SQL mode area, OceanBase currently supports all MySQL SQL mode, starting from version 4.2.1. The last part is backup and recovery. First of all, OceanBase is a multi-tenant architecture, so it currently doesn't support cluster-level backup and recovery. It only supports tenant-level backup and recovery. In addition, it currently does not support code backup, doesn't support the validation, verification of backup data, and doesn't support backup and recovery of some databases within tenants. Note that partial database refers to the system database. For our business database, however, can be fully backed and recovered. Next, we will introduce the OMS tool officially launched by OceanBase and how it performs daily migration and some data synchronization tasks. First, let's make a brief introduction to OMS. OMS is the abbreviation of OceanBase Migration Service. It supports synchronization data migrate from both homogeneous and heterogeneous data sources to OceanBase, enabling online migration of full data sets and real-time synchronization of incremental data. Align full data migration and real-time data synchronization, including full data verification. The picture on the left is the overall architecture. The OMS community version primarily includes a management console with a web interface that provides comprehensive management of various OMS tasks. At the bottom layer, it also includes the DB card component, responsible for data collection and conversion. This component retrieves metadata such as the structure of some of source-side data tables. There are also other components here, just like incremental components, incremental synchronization components, and full import components, and also full verification components. There are some basic service of components further down. For example, cluster management, resource pool management, high available components, metadata management, and other components to ensure efficient scheduling and a stable operation of the migration table. Migration module. Next is the introduction of OMS layer function. First of all, the top layer is service access layer. It includes migration project management, data source management, and operation monitor. Process orchestration layer mainly responsible for the implement of table structure migration, ensuring full data migration, incremental data migration, data verification and correction, and link switching tasks. The last one is the component layer. It includes dbcat, store, and supervisor, and others. Next, we list all the components of a brief introduction. The control components include 𝘰𝘭𝘶, GCM, and supervisor. They are the OMS console. The cluster management service and OMS proxy service, which is responsible for receiving and executing instructions issued by the cluster management service. The incremental parsing components are store and log parsing. Let's focus on store. It's used to pull and parse database transaction logs and store the parsed log records in a unified format. Downstream can consume incremental data from the store consistently without worrying about the difference in log formats between different databases. Because a store is compatible with the log formats of databases such as MySQL and PGSQL, we can directly pull their incremental data and save it locally. Log parsing is OceanBase's log agent. Framework components include increasync, full import, full verification. Increasync is an incremental synchronization and a full verification component. Others include InfluxDB. When deploying a migration task, if we need to monitor some data, we need to deploy InfluxDB. This is an optional choice. Next is the limitation of using OMS. There are some restrictions on database type and versions. If the data terminal is OceanBase Community Edition, basically all versions are supported. If the data terminal is other databases, currently OceanBase version 4.2.2 supports all of the databases listed below and their versions, including MySQL, MariaDB, TiDB, PGSQL, greenplum, and HBase. For the message middleware in data synchronization, Kafka and RocketMQ are currently supported. Next, let's briefly introduce how to deploy OMS. First, the deployment environment requires Docker to be installed on the machine, with the version of Docker no less than 1.13. The database used to store OMS meta information can be MySQL or OceanBase. Metadata mainly contains information about the data source, migration, and synchronization tasks we created, which will be stored in the database. Another requirement is resource allocation, which includes two parts, one for basic services and the other for migration and synchronization. For basic services, the requirements are 5 CPU cores, 8 GB memories and 200 GB of disk space. For migration and synchronization, the requirements are 8 CPU cores, 20 GB memory, and disk space of at least 10 GB. The disk here refers to the storage space mentioned earlier, which serves as a local store for pulling and saving incremental logs. The required size mainly depends on the production rate of incremental log from the database and the duration we intend to store them locally. If you synchronize to a big data component such as Kafka and RocketMQ, its resource requirements are at least 8 cores and 16 GB memory and a disk of at least 10 GB. There are several deployment options for OMS. Single node deployment, single region multi-node deployment, and the last one is multi-region multi-node deployment. Then there is the requirement for InfluxDB, which we just mentioned. It's used to collect and display historical monitoring data. If InfluxDB is not deployed, this monitoring data cannot be displayed. Let's look at the deployment steps. It's relatively simple. First, go to the official website to download the corresponding version of the OMS image package. Then use the docker load command to load it into our local image library. And then execute the command to get the deployment script. Note the parameters OMS image need to be replaced. We will give a detailed introduction to this parameter later. The fifth step is to execute the deployment. During this step, we need to specify the mount directory for the OMS container and configuration we parsed earlier. The configuration file path should be provided as an absolute path. After the deployment, you can log into the OMS web page. When you log in for the first time, you need to reset the root and admin user's initial password. If you want to check whether the entire OMS system is normal, we can log into the Docker and use the command to view the status of each component and its startup time. Here we will introduce the parameters in the configuration file mentioned above in the detail. First of all, deploying the OMS requires a metadata database to store our metadata, right? The previous 4 parameters are to specify the metadata database, including its IP port as well as its username and password. And then OMS will create 3 databases in metadatabase. They are used for the administration console, cluster management, and the heartbeat for the cluster management. Next is the parameter CMURL. When deploying a single node, we only need to specify the local IP. Be careful, do not use the localhost IP. If it's a cluster deployment, we need to specify a VIP and use the VIP to proxy each CM node. Next is CM location. It's the region code you can choose on your own. CM region is to specify the name of the region. CM region CN is to specify the Chinese name of the region. For the CM node parameter, if it's a multi-node deployment, it's the IP address of each component. CM is default parameter is the cluster management service. We can keep the default value. Do you still remember the InfluxDB we just mentioned? for collecting monitoring data. The remaining 5 parameters are related to it. These parameters are optional. If you need to collect monitoring data, the TSDB enabled parameter should be true. TSDB service could be InfluxDB or SeriesDB. Generally, InfluxDB will be our first choice. TSDB URL is the machine address where InfluxDB is deployed. TSDB username and the password are the username and password of InfluxDB. After deployment, log into the OMS page to configure a data source, which specifies the database from which data will be migrated. After logging, you will find data source management on the left side. Here, create a new data source by clicking the New Data Source button, which will prompt you to fill the data source information. Various types of data sources are available, including OceanBase, MySQL, TiDB, pgsql, greenplum, and HBase. Provide a data source ID and specify the region for the data source. If your data source type is OceanBase, you will also select a tenant type. Take note of the DB name field. Specify a database here. If you intend to migrate a single database, if migrating all databases, leave this field blank. After that, you will see the data source you just created. After completing data source entry, the next step is to configure our migration project. Click this button to create a new migration project, and then fill the name of the migration. Here you need to specify which databases in the source and which database is the target. There are 2 usage scenarios: data migration and disaster recovery with dual active mode. When selecting MySQL or OceanBase as the source and target database, the option for disaster recovery dual active will appear. Currently, OMS version 4.2.2 already supports MySQL and OceanBase to build a disaster recovery dual active usage scenario. Disaster recovery dual active means that the data can be written to both sides, both the source and the target side, with new data's entry continuously synchronized between them. For the scenario type, you can choose to support Earth unique key table migration only or all table migration. If you select all table for migration, please note that table without unique keys will not support full verification. The next step is to select the migration type, which includes schema migration, full data migration, incremental synchronization, full verification, reverse incremental, and others. Then select the migration object. Here you need to check which tables to migrate to the target. It should be noted that you have selected the migration that only supports unique key tables in the scenario type option. Then the tables that lack unique keys will not be displayed in the data objects here. The next step is to configure our migration options, including chart size mapping, as well as full migration, incremental synchronization, full verification, concurrent speed, and other content. It's important to pay attention to the write method. The direct load mode is a bypass import method, and our test shows that it achieves an import rate 5 to 6 times faster than the standard SQL write rate. I will also give you a brief introduction to the bypass import later. For the incremental synchronization, we can choose the time to keep the incremental records. We can also configure the specific parameters here in the configuration details. These parameters are also described in detail in the document on our official website. If you are interested, you can check it out. After the configuration is completed, we can start the synchronization task, including schema migration, full data migration, and incremental synchronization. Okay. And we also can use the pre-checks to check if we have any option that fails. Yes. After the configuration is complete, the next step is to manage the migration tasks and check the status of each one through pre-check. From the schema migration, you can see which table has been migrated. For data migration, check how much data has been migrated here. Next is incremental synchronization, which you can see how much data is synchronized and the performance of incremental synchronization. However, it should be noted that if you want to view the performance of incremental synchronization, you must have deployed InfluxDB. From the full verification, you can see that tables are verified and how much data are verified. The last one is forward switchover, which is the function to switch data at the business level. For example, at the business level, we write data to MySQL at the beginning, and our data is synchronized from MySQL to OceanBase. After the synchronization is completed, we can switch the business to the OceanBase. Other management tasks including storing tasks, viewing and modifying objects, monitoring components, and others. Click wheel objects to add and reduce the migration tables. From component monitoring, you can view the current running status of each component, and check the configuration parameters of each component. You can also make some modification here. You can also check the logs of these components. If there are some errors in the component, you can see it. You can see them. You can see their specific error message here. In addition to check the logs on the OMS interface, we can also log into the OMS container and enter the directory corresponding to each component to check its logs. The directories of each component logs are also listed here, including logs for the console, CM, store, and others. Next, I will give you a brief overview of how to tune the OMS tasks. If you found that OMS task is running slowly or have higher latency, Here is how to find the issue. There are several commands that can help. First, you can view metrics information by navigating to the task directory and executing this command, which provides detailed metrics. Here are some key metrics to monitor include the first one, source metrics, RPS, ROPS, and delay time. If the delay is high, check if there is a performance issue on the source side for data reading. The second one is sync metrics. This reflects the write performance, including write time, RPS, and delay time. Similarly, if there is a high delay time, check if there is a performance issue on the target site. Additionally, additional metrics. First one is sync time. Measure time required to write each record and each batch. The second is sync thread. Show the numbers of write threads, where 0 indicates the active threads and the 4 shows the total number of threads. Generally, you only need to focus on these metrics. Others are generally not used. Next, there is a command for analysis, which can give some analysis suggestions. You can also need to enter the corresponding directory and then execute this command. The S and the E parameters here are the start time and end time of the OMS task. During the time period, we will perform a performance analysis on this migration task. If there is no time parameter, the default analysis time will be 10 minutes. As you can see from the figure, there are suggested conclusions at the end, which will give us some optimization suggestions. This command is handy in the product environment. The third part of tuning is GC. Because every migration task of OMS runs in the JVM, this requires us to check the GC status. GC time is too long means that the young GC exceeds 300 milliseconds and full GC exceeds every second. Similarly, we also need to enter our corresponding directory and execute this command to check the status of JVM. If we find that full GC always exists, we need to adjust some parameters. How to adjust? The following are some commonly used methods. For example, increase JVM memory, reduce the parameters value, and so on. They are relatively advanced tuning methods. If you have questions about your environment, you can contact us in the OceanBase GitHub community or Slack community or even GitHub or even Discord community. After the migration task is completed, we need to release the task. If it's not released, it will continue to occupy CPU and memory resources. The operation of releasing the task is also very simple. Click the Stop button. After the migration task is completed, we need to release the task. If it's not released, here is the tab. After we click the Stop button, you will see the tab here. If the pause lasts more than 12 hours, the task may not resume. This is because the store component continues pulling incremental data during the pause, and after 12 hours, the initial data may be cleared, making it impossible to resume synchronization. After stop, the start and release button will appear here. click the release button to release the resource of the entire OMS tasks. After the release is complete, we can click the delete button to delete the task. When configure the OMS task just now, there is an option of direct load. Do you remember it? After selecting direct load, it's our bypass import method. First of all, the typical scenario of bypass import are batch data import, such as POC. When the memory is insufficient, the flow may be limited, resulting in longer import time. When the mem table dump is not fast enough, out of memory may be reported, and the import may fail. The result side has a huge table. And the solution value of bypass import or bypass method are and write directly to storage, reducing unnecessary overhead and improving write performance. Bypass mem table tenant memory size is still decoupled from data import volume. The last one is data writing efficiency is greatly improved. However, bypass import has a limitation. That is, the target table must be an empty table without any data. Only then can bypass import be used. Finally, let's briefly introduce data synchronization. Data synchronization means that we synchronize the data from OceanBase to Kafka or RocketMQ. OMS community edition can be applied to business scenarios such as real-time data warehouse construction, data query, and report divisions. For data synchronization, we support many message formats. Just like default JSON message format, 𝘔𝘁𝘬𝘭𝘰𝘶, 𝘗𝘗𝘴𝘵𝘁𝘐 JSON, SharePlux JSON, Maxwell JSON, and other JSON message formats. Okay, the next is the last part of our today's lesson. Let's continue to introduce OB-log proxy. OB-log proxy is OceanBase's incremental log proxy service. It can establish a connection with OceanBase and read incremental logs, providing CDC capabilities for downstream services. CDC means change data capture. OB-log proxy has two modes, binlog mode and CDC mode. Binlog mode enables OceanBase to be compatible with MySQL binlog. It supports real-time synchronization with existing MySQL binlog incremental parsing tools, allowing these tools to seamlessly transition to OceanBase. CDC mode is used to solve data synchronization. In CDC mode, OB-log proxy can subscribe to data changes in OceanBase and synchronize these data changes to downstream services in real time, achieving real-time or quasi-real-time replication and synchronization of data. Okay. The installation steps are relatively simple. We have two methods to install OB-log proxy. The first method is RPM installation. The first step is to download and install the RPM package. And then you can upload it to the server and execute the installation command. And the second method is to use the source code to construct OB-log proxy. We require the version of CMake to be version 3.2 or above. Then use this command to install. And then use the CMake command to compile. After the installation is complete, the next step is to modify the configuration file. 𝘤𝘰𝘏𝘂𝘵 has many parameters, but we don't need to pay attention to all of them. In other words, we don't need to modify most of the parameters. Here, we only need to pay attention to a few parameters. For example, the OCBase username and the password. Another thing is that we want to enable bin log mode. We need to set bin log mode to true. Currently, we use these three parameters, and most of others don't need to be modified. Next, we will briefly introduce the bin log mode to you. Bin log supports two modes subscription. The first one is position mode subscription. In position mode, the subscriber is based on the specified bin log file name and offsite. Also known as bin log position, in this mode, subscription is based on physical position. The other one is GTID mode subscription. GTID means Global Transaction ID. It's an mechanism for uniquely tracking transactions in distributed environment. In GTID mode, each transaction has a unique global ID, unaffected by bin log changes or offsites, allowing subscription based on logical positions. The right feature is the architecture of 𝘤𝘰𝘏𝘂𝘵 bin log mode. Here, I will give a brief introduction. First of all, OceanBase is our data source. That is, we need to pose the incremental log of OceanBase and parse it into the corresponding bin log. There are two modules involved here. One is BC module. BC means bin log converter, which mainly pulls and processes the C log and then converts it into a bin log file according to the bin log format and stores it on the disk. The other is the BD module. BD means bin log dumper, which mainly provides bin log subscription service for downstream subscription request. Then there is the 𝘤𝘰𝘏𝘂𝘵 module, which mainly includes some management tools such as BCM and BDM. All other business modules includes downstream subscription services, access bin log through 𝘤𝘰𝘏𝘂𝘵, and then 𝘤𝘰𝘏𝘂𝘵 will start the BD module to send bin log to the corresponding requests. For example, Kernel and 𝘖𝘰𝘐𝑑𝑐. Then let's look at the compatibility comparison between bin log mode and MySQL bin log. Currently, all commands related to MySQL bin log are supported except reset master. Here we need to pay attention that OceanBase's DDL syntax differs somewhat from MySQL, as OceanBase's include extended syntax that may not be parsed by MySQL compatible tools. To address this, OceanBase offers compatibility support. We recommend setting initSQL in 𝘤𝑰𝑃roxy to enable show DDL in compatible mode. Once enabled, OceanBase shows create table output will be fully compatible with MySQL syntax. Then other commands include MySQL bin log replication protocol and MySQL related environment variables are also supported. There are also some limitations when using bin log mode. The first one is bin log mode does not support the extend semantics for enum and set types implemented by OceanBase. For example, the number of site definition supports more than 64, supports duplication, and enum supports inserting undefined data. The second one is binlog. Binlog mode does not support varchar definition. The third one and the last one is binlog mode does not support GIS type. How do we configure binlog mode? First, before we use binlog mode, we need to confirm the version information of the current OceanBase and OB proxy. Their versions must match. Then configure our OB proxy. As mentioned earlier, we need OB proxy when using binlog mode. First, configure the service address of OB log proxy for OB proxy. Then configure the address of binlog service. The second step is to start the binlog service. The first step is that init circle. Finally, verify whether the configuration is correct. The next step is to configure our OB log proxy. First of all, the default directory of OB log proxy projects is user local OB log proxy, and the default configuration is placed in the config.json file. The second step is to modify the configuration in the config.json file. The modification of the username and password are optional. If you want to change this, the user must be a sys tenant in OceanBase. Note that the username here should not contain the cluster name or tenant name. Must have read permission for the OceanBase under the sys tenant. How to get the encrypt username and password? We can use these commands, and then save the results to the OBSys username and OBSys password configuration items in the config file. The third step is to start the OB log proxy service. The first step is to creating a binlog service and connect to OB log proxy. You can see the specific steps by yourself. I trust you. After that, the OB log proxy binlog mode has been created successfully. Next is other binlog operation. Here are some examples. Release the binlog service, clean up the binlog, and get the binlog service status. Before executing this cycle, you need to connect directly to OB log proxy. Next, we will introduce the CDC mode. The CDC mode is also relatively simple, and we also need to deploy our OB log proxy. CDC mode is used for real-time data synchronization. In CDC mode, OB log proxy can subscribe to data changes in the OceanBase and synchronize these data changes to downstream service in real time, realizing real-time or quasi-real-time replication and synchronization of data. From the following architecture, we can see that the OB log reader module of OB log proxy will pull and parse the log and send it to the downstream in a certain data format, such as Flink CTC, ecological tools, OB log client, and others. Using CDC mode is similarly to configuring binlog mode. The difference is that we don't need to set binlog mode to true in the config.json file. It should be noted here that before using OB log client subscription, you need to install the Marvin environment. Here is the reference code of OB log client, which is also available on the on our OceanBase official website. If you are interested, you can test it in this way. If you have any questions, now is the perfect time to ask. Let me check. Okay, no questions. Before we wrap up, I'd like to remind you that our next lesson will be on the evening of next Thursday, where we'll be covering the second part of ocean-based migration and synchronization. We look forward to seeing you then. You can also reach out anytime through our OceanBase GitHub, Slack, and Discord community for further assistance. We are always here to help. We will be sharing how you can access the course materials and today's presentation slides in the comments section of this video. All the resources are free. Don't forget to subscribe to our OceanBase YouTube channel and join our community to stay up to date and get involved with us. See you guys. Bye-bye. Okay.